Welcome back to our Huawei eLearning course SDN Architecture and Ecosystem. In the third chapter we will talk about the SDN Value Proposition. Or in other words, what are the real advantages of SDN and why should a provider now invest in this new architecture called SDN? One major advantage of SDN is its characteristic to ease and so to speed up the deployment of innovations in the form of apps to the network. As we have seen, due to the openness of SDN architecture and the direct programmable northbound and southbound interfaces, this paves the way for an easier and faster implementation of new services. This can be achieved by the centralized SDN network architecture and its core component, the SDN controller, which is responsible for the control of the forwarding devices. So the time frame to implement a new innovative application in the network can be shortened from years in traditional networks to just a few months in SDN networks. Another advantage is that networks will be simplified with SDN. Due to physical separation of control plane and data plane, all the control operations will be handled by the controller. This means that many protocols such as LDP, RSVP, MBGP or PIM, etc. will no more be required because all the calculation work, for instance to do the route calculation, etc., will be handled by the controller. And the results of this calculation process will be passed on to the forwarding devices. In SDN networks, all these traditional protocols will no more be required and just be replaced by open standard southbound or northbound interfaces. Another advantage can be derived directly from the previous one. SDN will allow the usage of so-called white box hardware. The term white box hardware refers to the ability to use generic off-the-shelf or standard switching and routing hardware for the forwarding plane. White box hardware are based on an operating system which may come already installed or can be purchased from a software vendor or loaded separately. A common OS for white box switches is Linux-based because of the many open and free Linux tools available that allow the administrators to customize the devices according to their needs. Another advantage is the automated service provisioning in SDN networks. In SDN networks, the controller has the global view of the network topology. Applications are running on top of that controller. The controller provides network information, topology or link information to the app through the open northbound interface. With the centralized architecture, the app can easily provide automated global service provisioning, for instance, layer 2 VPN, layer 3 VPN provisioning, etc., for the entire network. A further advantage can be seen if looking at network path and traffic optimization. In fact, also for traditional networks, there are some traffic engineering techniques to solve shortest path congestion problems, for instance, if doing traffic engineering with MPLS-TE. But it's still a fully distributed approach. It will lead to previously described business order dependency problems. If using other traffic engineering protocols like soft state-based RSVP, this has led to scalability problems. If using SDN, the network provides an end-to-end network view from scratch. So what does it mean now to an existing telecom network if implementing SDN? Programmability features in traditional networks are poor. Therefore, we need to upgrade networking devices in current networks into SDN-capable devices, supporting, for instance, OpenFlow protocol. There is one new device in the network, the SDN controller. For the future, the upgrading procedures will be much more easy than in traditional distributed networks. Only the controller needs to be upgraded. No upgrades are necessary for all the forwarding devices in the SDN network. So this module gave an idea about SDN value proposition, or which advantages a provider can expect if using SDN. Thank you for watching.